So now that you've seen the Pac-Man game and we've persisted the high score as Ivan 1, let's go ahead and migrate the application from AWS to our GKE Kubernetes cluster. And to do that, we're going to use a proof of concept tool called KMT, which stands for Kubernetes Migration Tool. And as we launch the tool, I'll go ahead and talk about some of the ways in which it works. So here's the usage for it, and it basically requires you to specify the from context that you're migrating from, the to context that you're going to migrate to, the namespace that you want to migrate, as well as the zone and DNS that's associated with your application. In this case, we're using Google's Cloud DNS, and so the zone name that we provide here will be the zone name that I've created to host the DNS entries for this application. And then the DNS name is the DNS name ifontlabs.com that we're using to host this application. So let's go ahead and migrate. And we want to migrate from the context AWS US East 1 to the context GCE US West 1. We want to migrate the namespace Pac-Man using the zone ifontlabs and the DNS ifontlabs.com. So as this tool is running, basically it just does some basic error checking to make sure you haven't specified any invalid arguments that are going to create problems as you run this. It then uses the from context to export all of the Kubernetes resources for your application that's in the namespace that you specify. It then takes those resources and imports them into your target to context Kubernetes cluster, in this case our GKE US West 1 cluster. And it waits for those resources to become available. In this particular case, we're actually needing to replicate our data as well, since we have that stateful component. The way it does this is actually by creating a Mongo replication set, and it will create a replication set with a secondary in the GKE cluster so that the primary in AWS replicates all its data. And once it's done replicating the data, it will then be ready to serve the application and all its data. But before we delete any of the Pac-Man resources in the source Kubernetes cluster, AWS in this case, before it actually deletes those, it needs to handle the routing changes. The routing changes are handled by updating the DNS. In this case, we're changing the DNS from the AWS load balancer, which gives you a dynamic DNS, to Google's load balancer IP for the Pac-Man resource. And that's being provided by importing those resources in the Kubernetes cluster on GKE. So once the DNS update is completed, we will then be able to actually talk to the Pac-Man game and have it be served out of our GKE Kubernetes cluster. And only once the DNS has been updated so that it's pointing to the load balancer IP in your GKE Kubernetes cluster, it will then delete all of the Pac-Man resources in the Pac-Man namespace in the source cluster. And you can kind of see and sort of follow along in the output of the KMT tool. But you can see that one of the last things it does here is actually creates the update to the DNS. And you can see that once the DNS entry is executed, that transaction is an atomic transaction that gets executed. Once that's done, and the Pac-Man game is now being served out of the GKE Kubernetes cluster, it goes ahead and deletes the Pac-Man namespace in the source cluster. So to show you kind of what's happened, let's take a look at both clusters again. And you can see that our AWS Kubernetes cluster has no resources running, and our Google Kubernetes cluster now has the Mongo and Pac-Man game, the Mongo and Pac-Man pods running on it to serve the Pac-Man game. If we take a look at the DNS entry, we now see that pacman.ifontlabs.com was updated using an A record type instead of a CNAME record. That's the difference between AWS and Google's load balancer. And we can see that the IP address now points to the new Pac-Man service IP provided by our Google load balancer. So let's go ahead and go back to the game. And we can see here that if we refresh, we're now running out of our Google Cloud Kubernetes cluster in the West region. So let's go ahead and play around. And save as Ivan2. If we save that and view the high score, we see that Ivan2 was persisted here, running on Google's cloud with a high score of 190. And we can also see that our Ivan1 score that was run on our AWS cluster is still there with a high score of 150.